Hey there, it's Mark with Alchemist Camp, where we learn Elixir by building things. And this time we finally get a chance to get back to learning or to building, learning and building, learning through building our tic-tac-toe game. The last several episodes have been devoted to building the initial version of alchemist.camp, which is a great site I suggest you check out because it's got all these videos on it. But it is nice to be able to get back to what we were working on. We're going to build a state machine into the game this time. If you don't know what that is, check out the video in the description below, which is a whiteboarding session of what state machines are and why it makes sense to put them into games and how they can help. With that out of the way, we're going to continue building this that we started in lesson 8. I'm just going to move a couple of functions from the tic-tac module into the square module because they kind of make sense. One is to make a new board out of these squares, and the other is just to get a map set of a bunch of squares. So it's basically we can make a new board with the squares. And it's also good that we have this magic constant all in one place. In fact, let's make it not so magical. We'll call this board size, and that will be a module attribute up here. Okay, now the next thing is building the state machine. There's a lot of code today, so I'm just gonna fly through it, but I'll try to be as clear as I can. If you don't understand what's going on, just write a comment. I'm pretty nice about answering them. Module is tic-tac.state, and we're gonna write an alias to tic-tac.square and to the tic-tac.state module, just so we can access what's in it. And we'll set a module attribute of the players, and the only valid players in tic-tac-toe are X and O. Now we're going to set a def struct with everything that's going to be in the state, as well as some initial values for it. And we're going to call the state of the game itself status, and all the information that we want to be passing around all the functions is going to be in this struct. So the statuses are initial, choose player 1, so that's right when you start a game but before you've picked anyone. Playing, we'll keep track of who's playing in a separate piece of state. Game over, and winner reported. Okay, so the struct has status. Default will be initial. Anytime we make a new game, it will have status at initial. Over is whether if the game is over or not. Turn is whose turn is next. Winner is who's won the game. Board is all the data in our board, so we're going to have to change a few functions in our tic-tac main module. And UI is something we'll get into later, but this tic-tac-toe is going to be modularized so that once we're done making this set of rules in the state machine, they can be played by a command line interface, which is the first one we'll build. But later, when we build the Phoenix website, we can use the exact same state machine, exact same set of rules, and just pass it a different UI, and it'll be very easy to do. Just a comma there. All right, so make a new state with new, and we'll just return OK and a state. And because of the def struct above, this state that we return will have all of those initial settings. We'll also make a UI version. Might as well do that now. And we pass it to UI. Same deal, except it has the UI that we've passed it to drive it. The primary function in this module is called event. An event takes a state and then an action inside a tuple and the action may or may not have some other information with it. So def event takes a state, and the first state we have to deal with is status initial. We're going to keep track of the state. Okay, just to make sure you follow this, these are two arguments. The first is a state, the second is the action. Oops, that's backwards. And this function will only match if the state passed into it has status initial. And this equals state just matches it, just binds it to this variable called state, so we can use state in here to see what was matched. Then the second part only matches actions where the action is choose player 1, and there's another variable given to it, which is bound in player. So we have access to state and player inside, and the only event calls that this matches are those with matching information, as we have here. Right, so when we get the state, tic-tac-check player, which is a function we wrote back in lesson 8, player do. So if that function returns OK and a player, then we update the state, say OK. And we update the state to be the same as it was, except the status is now playing instead of initial, and turn is now the player that was passed in. So whoever was chosen to play first, it's their turn now. And if anything else comes in besides OK and a player, then we have an error, invalid player. And that's it for the first, oh, we need another end. Okay, that's it for the first definition of event. And now we need to handle when the status is playing. And the action is going to be play, and there's another element passed in the tuple, P, which is the player. And when P is not one of the players that we defined up here on line 3, we'll return a tuple with an error, and the kind of error is invalid player. Okay, then when the state is, when the status is playing and a player is passed in, well, the action is play, the player is passed in, so we want to match if it's the same player whose turn it is. So we actually need to get the turn out of the state as well. The turn is P, which just matches a variable to P, and then the player is also P. So this function will only get called if the turn is the same as the player is. They could both be X or they could both be O. And we still want to know what the state is inside our function, so we will capture it with a match here. Say OK, and return an updated state. Status will still be the same, that's still playing, but we'll change turn to the other player, and we need a function to get the other player. And we'll make that down here. Other player, P. And case, let's see, case player do. If the current player is X, then the other player is O. Just gonna scroll this up a bit. If the current player is O, that's huge, but it's probably good. The other player will be X. And if the player passed in is not X or O, then we have an error. So with that helper out of the way, when the status is playing and the person who makes a play is the same as the person whose turn it is, we say okay, and we update the state to be the other player. That seems pretty good. Then when the status is playing and it's a valid player, but it's the wrong player, we need to have a way to handle that. So status is playing and the action is play, and to anybody else, then actually just make this a one-liner, then error out of turn. So event state status playing equals state, just so we can capture it. And actually we don't need this one. Equals state, and then the game over action and variable over or not, and we'll do a case of over or not, and if the status of that is not over, then we return okay and state, nothing changes. If status is game over, then it's okay, but the state is updated to state game over to game over, the atom game over. And if we get any other status, that's an error. Invalid game over status. And speaking of errors, this will never match since I called it gave over instead of game over. Fix that at our end. Okay, the next question is the check for a winner action, because we've got to check for a winner. And we could check for a winner after the game is over or before the game is over. I think we should check for a winner before the game is over, because finding a winner is one of the ways the game will become over. So I'm going to put this up here since we're going in chronological state order in this module. So event, the state is going to, or the status is going to be playing. The action is going to be check for winner. Check for winner is going to send it a winner. Case winner in players do. If it's true, then we'll return okay, and the game state, which is updated, so it's going to be state, and status is going to be game over, which means down here it should have been status game over. Actually, this should be state status game over, and this should also be state status is game over and over is true. Do we even need over? I don't think we need over. Yeah, we don't need over because game over is a status. So we'll get rid of that one. Just make sure that we're not using it. Okay. And that is all that has to change. Not true. Not true. We found a winner. Case winner in players. So we found a winner, so status winner, and then winner has to be updated in this one. So status is game over, winner is winner. Down here in game over status, we do not know who the winner is. So after we find game over status, we will have to check for the winner. And if there was no winner, we'll have to make it a tie. Okay. And it's probably simplest if we set this up so that the only time we check for a winner is right after a play. So we always check for a winner after someone plays. And if there is no winner, then we check for game over still. So we might have game over when there was no winner. In this case, we have game over, status game over, and winner is going to be tie. That should do it. Okay, state line 30 is missing a terminator. .32 is missing one. Status is playing. Okay. Same deal here. Probably forgot one after one of the cases right here. Winner, winner, do, and otherwise. We can't use the in inside of a case statement. Square, where do we use board size? One column, row size, and row and board size. Oh, we never set the board size. 1.3. Players was set but never used in tic-tac. That's true because we moved some things out of here. Tic-tac-square is not available. Okay. Square. Because it used to be off on its own, and now it's tic-tac-square. .34 and 35. Because we didn't capture state. Okay, and that should be everything. Yay. Let's alias tic-tac.state and .new. Oh, this should be new. So this time we've got a whole bunch of modules. Well, we've got 3 modules loaded up into IEX. The way we can recompile them all is just recompile. Everything's set up. So state.new, that looks pretty good. All right, so let's set OK and state equal to state.new. State, good. State.board, good. State.status, state.turn, okay. Now passing in our state to state.event, state, and choose P1 and X. Excellent. We can't do it again because it's already been done. Oh, we should get a better error than that though. we need to set up a catch-all. So let's do that really quickly. So this is just going to be an event that matches everything. Invalid state transition. Keep track of these. State, action, and this is going to have to be an object. State, action. Give that another try. State status. Okay, we're playing. So let's say state.event state, choose player 1. And invalid state transition. We've got that state and it's told us the action. Okay, what happens if we go back to a new state and then with our new state we choose player Y, invalid player. Very good. How about if we choose ASD? Well, it's not even defined. Okay, we choose X. Okay, so now we'll say okay, and X's turn. Okay, so now say we pass that state to play X. That's great. Now it's O's turn. Say it's X's turn and O tries to play. Out of turn error. How about if T tries to play? Invalid player. How about if we have a fake event? That looks pretty good. Although I think we can just pass status. We don't need all the state. Dot status. Yeah, that's better. Okay, this is a good stopping spot. With the state machine essentially set up, next time we're going to connect the main tic-tac module to the state machine. And that's going to be pretty quick because we've already made a lot of functionality in the main tic-tac module. And all it has to do is just send these events to interact with the state machine and then get the new state back and handle the response. And so we may have time to also build out the UI in the next module, which is also going to be pretty quick because it's just going to be handling events it gets from the main module. The main module is going to kind of connect the UI to the state machine. And that just leaves the challenge. The challenge for this time is to create a state machine representation for another game that you know. You could pick a card game like Hearts or Blackjack, or you could pick another board game, or you could even pick a children's game like Capture the Flag. All of those games can be represented by states and events that transition the game from one state to another. Think about which states can transition to which states. For example, in Capture the Flag, you can't go from hiding the flag to losing the game. You have to go from hiding the flag to ending the hiding the flag state and entering the normal game state where you search for each other's flag. And then someone has to capture a flag. And then when the flag is captured, it has to be taken back to their side. Think about which events can transition which states into which other states. And you may have noticed that today's lesson was a little bit error prone. It would have been much easier if we'd had a data structure that held all of the states and all of the actions and mapped states and actions into transitions into other states or error messages. What sort of structure do you feel would be convenient to have this data in? And also, what kind of structure do you think would work better for tic-tac-toe? If you come up with anything interesting, definitely leave it in the comment or leave a link to it in the comments. YouTube's not so great about code formatting. And don't forget to check out alchemist.camp. And until next time, code on.